Hello and welcome to a special CircuitPython Day 2023 as seen on the show and tell. It's Friday, it's 7:30. Pretend it's kind of like a Wednesday, but it's not, it's Friday. And it's CircuitPython Day. There was an entire schedule of videos and events and posts and more all throughout the day. And this is kind of capping it off with a show and tell. It doesn't have to be a CircuitPython based project. We have some stuff we're going to show that happens to have some CircuitPython stuff, but this is the theme. You know, you got to use the graphics for some. So we'll start with some of our team members. They might be showing some CircuitPython stuff, but again, you know, show anything you want, just like every single week. This just happens to be CircuitPython Day. All right, first up, Anne. Happy CircuitPython Day. What you got going on?
Hi, everybody. You might have seen that I've been doing a lot of PCB art. You know, my first project was this jewelry. My second one was this NASA badge, which lights up some of the stars when you turn it on. And the latest one ups the ante a little bit more. I saw on the interwebs this cool Star Trek LCARS door control panel, and they have it in various things. I think it's the next generation. So I thought maybe do a take on that, except with plexiglass and screen printing or however they make it. Again, use circuit boards and have all the hard parts done by a board house. So I designed it in an Affinity Designer. You can design the graphics however you want. You can pick the layers, which layers of the board represent which colors. The logo shows up in metallic currently, and then around it is the bare circuit board. But this isn't just like for show. On the back are places to put circuitry. And what I've been doing, I just got these, so I've been bringing up the board. I put a capacitive touch chip that Adafruit has in one of their breakouts, and Lemoore has Circuit for. And I put LEDs. Oh, there you go. You can actually see the LEDs lighting on the back because I'm touching it as I'm holding it. There we go. But the methodology is you touch. Let's see, I gotta get. There we go. You touch the. Let's see, get the right. There you go. So if I touch 5, I am the little light behind lights up the number 5. So it is working. It's not working perfectly because if I touch the number 9, the light for number 1 works. So it's kind of backwards. So that's okay. Circuit boards aren't too expensive, actually. So I will work on some of the circuitry. I know the chip works. I know the design works. I just need to reroute some of the signals to get it to do what it's going to do. And then the next iteration, I can wire up all 10. Now, the logical thing is, well, you're just lighting up lights. Well, it does make a cool thing if you have one of these near your door. Or you can change up the circuit a little bit and have a microcontroller, and actually, if you enter in a certain code, it unlocks the door and they don't swing open like in Star Trek, perhaps. Or, you know, whatever fun thing you want to have when you actually enter and push things. So I just kind of geek out over the aesthetic of this, and it's not too hard. So, I mean, you go from Affinity Designer to Winter Bloom's online free utility called Gingerbread, and that converts the drawing outlines to KiCad. And you import that into KiCad as a footprint, and then you make your design, and it's kind of auto-magically, you know, it has all the pretty stuff in it besides your electronics. So I really like it, and I appreciate Lemoore giving me the chance to work on this.
Okay. This is a great project. And what's neat is kind of a combination of the badge art that we see out there, and then this turning into like a functional, like heirloom electronics, like something that you'll actually want in your home. That's like, hey, look at that over there. I like the aesthetic too. It's like Picard got a like flat screen TV to watch like the Spaceball game or something like that. So, all right. Well, thanks so much, Anne.
No problem.
And if folks want to find out more about it, where could they possibly?
Well, I've been posting some stuff on my Twitter, Anne_engineer. This will be written up as a Adafruit Learn guide with step-by-step, all the files, open source, so they can either make it or remix it, do whatever they like with it once I figure out the little kinks.
Yeah. Okay. All right, so stay tuned to the Learn System and more, everybody, if you want to check this out. All right, thanks so much, Anne.
All right.
All right, JP, happy CircuitPython Day.
Hey.
What you got going on?
Happy CircuitPython Day. So I had a lot of fun doing a panel discussion and a workshop show today, but I didn't build anything. So an hour ago, I decided I better build something for the show and tell, and I was able to quickly get together the parts to add on to my joystick, PC joystick seesaw adapter demo I did on Tuesday, which allowed me to use an old flight stick. That's this Radio Shack flight stick that I got just a couple months ago fortuitously at the thrift store. And I was using it to drive a little graphic demo on this OLED. But right at the end of the show, I said, you know, you could use this for all kinds of things, including maybe sort of a XY servo mount, shoulder mounted puppet or something like that, or other type of props. So I grabbed a couple of servos and brackets that I put together years ago for a project, wired them up using one of our little servo feather wings, and then added the code in CircuitPython to the QT Py that drives all of this to be able to now pilot this little servo rig. You can look around.
I'm gonna give some props to CircuitPython because like this is normally not the type of project that you're like, I'm about to go live on a video show. Like just being able to do this that fast is
This is actually a really great project.
This is really hard to do normally.
And it's very fun to kind of just talk to the little fellow. Hello. And so I still have the OLED demo going, so that shows like some button press stuff happening.
I think because that could be eyeballs or it could be the mouth or something like that. Yeah.
For sure. And we've got the support here to do a rudder and a throttle as well. There's sometimes like 4 potentiometers on these joysticks. Mine has a third one, which is just this throttle you'll see on my OLED. I'm able to move.
It already has like an alive nature to it. One of the things when we do the Circuit Playground Puppet Show, when I was learning puppetry, is you keep them kind of moving and breathing all the time because the second they're still,
then they die.
So I kind of like that it has this it reminds me of the little creature that used to hang out on Jabba the Hutt.
Yes, that weird little.
It's like it's already like, like
there was like some slapstick humor needed.
Yeah,
totally. Little rock puppet.
Rabbit eat him at the end or something.
I think he was eaten.
He does get eaten. Yeah, he had it coming.
Yeah, this is already neat.
And what's interesting is like how hard this used to be with an Arduino, like JP. Like you remember, like people doing this kind of project. You know,
and here's my thesis.
It would be like it'd be like weeks and weeks. This is something you just like banged out in an hour, and it's like I can see like you probably just read the data and then mapped it and then wrote it. And especially with robotics, you want to have this fast iteration because you're always tweaking. Like, oh wait, my XY is swapped and then it's inverted, and then like there's always 8 combos for everything.
Yep. Yeah, and it was at first, and it was just a
like having a REPL with robotics is really good because you could sit there and like do stuff and do it real time instead of compile, wait,
iteration,
compile, die, compile, die.
So helpful.
Okay, this is we didn't plan this. We didn't know you were coming on. This is like probably one of the best examples of a scripting language like CircuitPython for rapid iterations for things like robotics. So you're the poster robot of this today.
Thank you.
All right, nice
take a bow, robot friend. All right, JP, good work.
Bye.
Be CircuitPython Day. All right, Scott, today was a lot of your handiwork out in display for CircuitPython Day. Congratulations.
Yeah.
CircuitPython Day.
Yeah, but also props to Kattni for organizing it.
Yay!
if you watch my stream, you know I was late. So like, I'm not a great organizer. So
Well,
thanks to Katney for doing
it's
that.
all streamed and recorded. So what's late anyways?
It's true. It's very true. So I showed this on my stream earlier, but I wanted to bring it here. So I've been working on USB host, and actually I want to take John's project and use a USB joystick for that. I think that'd be very cool. But I was doing, I'm gonna synth. I expected John to do synth stuff. Yeah. So can you hear it if I go?
Yes.
Beep bap beep bap.
Okay, that's so. What I've got here is I've got like one of these MIDI keyboards. It's on my lap and it's plugged into an IMX RT1060, which is an NXP board. And I've been testing the ability to, I wrote a library so that you can read MIDI from a USB device using upcoming, like current CircuitPython USB host. And I wanted to see how well it works. So the thing that I was having fun with, and I've had fun with previously, is that this is also a sequencer. So there's like some sort of sequence in here already. So it's doing this thing, but there's also a rate knob, so we can see how quick it can handle. So as I increase the rate, it's actually individual MIDI messages going up USB host. So it is kind of a good test to see like how much data you can get going.
Crank it.
So that's as fast as it goes.
That's a lot of data.
It's a lot of data, and because no notes are stuck, I think we're actually getting all the data too, which is super fun. And it like the square waves bring back all of these like memories.
So the MIDI keyboard, the USB output is plugged into an RT1060 dev board,
right?
And then that's running synth.io to generate the tones. No.
Yeah. Yes.
Okay.
So there's three things plugged in. This one is power.
Okay.
This is USB OTG, right? So like taking micro B to a USB A, and then this is just to the speaker that's on my desk.
Okay, so you really did make a keyboard powered synth. So you're testing synth.io and USB host.
Yeah, I mean it's kind of like the first opportunity I had to play with synth.io, and thanks to ToddBot, and I forgot to say this earlier, but ToddBot, has example code already that takes MIDI and produces synth.io. So I just took the little bits out and said, now use USB host instead of the USB device MIDI.
This is neat, actually. It's like you've got a little synthesizer generator going on there. Is this the original Yamaha MIDI keyboard that you had like 7 years ago that you like?
No.
Do you still have that?
I don't have the big one. I was thrifting for a while and I got some bigger Yamaha old keyboards, but I only kept one of the smaller ones.
Okay.
Because I only have so much space.
Okay.
Although one thing that I couldn't help myself but pick up when I was at a PC parts store was an old Sound Blaster.
Yeah.
So that's also in my closet.
I say it's just an 8080 bus. There's no reason why CircuitPython can't have ISA support.
Oh, you're tempting me. Yeah. We'll see.
So thanks for showing another example of one of the things we like to talk about with CircuitPython and Python on hardware. JP, other robotics. I really like it when artists and musicians can do the things they want to do, and the learning curve isn't in the way. Like you'll be able to being able to do stuff like this is usually really complicated and hard. Yep. Now it'll be a lot easier. So another good example of why Python, or specifically CircuitPython, is really good for folks who maybe they've never even done Python programming before, but this is a great reason to start or consider it.
Totally, yeah. Like if you watch the deep dive I did earlier, I went over the code and it's like 10 lines of imports, 20 lines of setup, and 10 lines of loop. Right, like it's 40 lines total to have this demo working.
That's great.
Pretty good.
Nice.
Okay, well, thank you so much, Scott. Congrats on a CircuitPython Day.
Yeah.
Folks can watch the entire playlist and all the videos from the day. And we, of course, do something every year. We also do the what do you want to see in CircuitPython at the beginning of the year. And then we do a CircuitPython Day. We hope to have like a physical event at some point, but we understand the last couple of years have been a little weird. But that's fine. we'll see everybody soon. Thank you so much, Scott. And next up, Seth, what you got going on?
Hey everyone, happy CircuitPython Day. You talk about how CircuitPython is making it easier for people to do things like art and JP's little animatronic control with the joystick. And so when I started in the CircuitPython community, I really wanted to make FPGAs work with CircuitPython. It seemed like something that just needed to be done. And so I've been working on, so I have this little feather wing here. It's got a little lattice FPGA on it that you can program over SPI, because that's how you program this particular one. And I thought, well, it's going to be difficult to set up the timing and everything to get the FPGA to program properly. But it turns out it was actually a lot easier than I thought. And it came together pretty quickly, thanks to Scott and a few other in the community that just kind of were like, hey, double check that. And so it came together. And so I've got a little blinky thing. So there's a little tiny RGB LED on there. I don't know if you can see it. It's like the size of a grain of sand.
Yeah.
So I've got that set up with a little Raspberry or RP2040 board that I made. And so it'll program it. You see the done light come on, and then once I move the USB power over to the USB pin, it'll just cycle through the counter. And so for me, this is just another way that I want to make CircuitPython more enticing to people. And actually, just want to show real quick how simple the code is for
fire up.
For this.
Open, and I'll share it into the stream.
All right. So this is just like a quick example, and some of this isn't even necessary, like the timing, but basically you just you pull in the library, you set up your SPI device. You can use built-in SPI or BESIO, pass it in with a chip select and a reset pin, and then your file, and then you just program your FPGA, and it's done. So we take care of all the heavy lifting in the back end and make sure we get all the timing right, so you don't have to worry about it. And then, so you can take start using lattice FPGAs with CircuitPython now.
It's kind of funny. You're making it too easy, and you're making it so easy you can use one non-scrolled panel in Moo.
Yeah.
You can read the code without scrolling. It's not a million lines. That's pretty impressive.
Yeah, I wanted to make it as simple as possible, and I even set it up where you can change files. So if you've got enough space on your drive, your CircuitPython drive, you can load multiple bitstream files in there and just read one in, do something, read another one in, do something, and it's quick. It's easy. So that part's easy. All you got to do is learn, Verilog, and there's tons of stuff for doing that already, especially people in the community that are doing that. So
yeah, I was talking to some educators, and they're like, "There's no good FPGA stuff," and I was thinking about how if you're going to try to teach this, how would you get someone started? How would you have that 5-minute time where it's like, I did something?
Yeah.
Something happened. Like I did something and something changed. So
yeah, exactly. And that's the goal of this, is just to make that step easier. So if you don't have to worry about it, you can just, you can do the things that people are doing in large companies with Python now. And I think that's pretty cool. So.
I like the idea that you could even explain how some of this works on one screen. Another thing that educators had told us, this was like a while ago when we first started developing Circuit Playground, which ultimately had CircuitPython on it, is they're doing one screen at a time. They're projecting stuff in a workshop setting or a educator setting, student setting, and they have to talk about what's on the screen there. And it's hard to get a concept of like, here's like 10 or 15 lines, and something in there has a concept you're going to explain. Otherwise you have to scroll and scroll and scroll and scroll. So That's a good example. Where can people find out about this?
This is called IcePython. It's on GitHub. I've shared it on Twitter, and I'll throw a link in the Discord as well. It'll be part of the community bundle. I've got a few small things that I want to wrap up, a few more examples, and then it'll be in the community bundle for anyone to use.
All right, Seth. Happy CircuitPython Day. Thanks for coming by.
Yeah, thank you.
Very sneaky.
All right, so Our Lady is going to show two things. You want to show this rendering of a...
Well, how about we show...
Or the screens. What do you want to do?
Either one, whichever is easier.
Okay. Well, why don't we do both?
Okay.
Because you have a picture of something.
Yeah.
And then we have some screens.
Yeah. So this is
a
a driver board I designed today. It's going to run CircuitPython, so it's thematic. And I kind of took the Matrix Portal S3, which I just designed, and I sort of took out the RGB Matrix part, and I put in a TFT instead, and also a couple other things changed. Like it doesn't have a 5-volt output, and it has this little LED PWM driver. And this is for driving unusual shaped TFT displays. There's two standards, it turns out. There's like rectangular and there's like everything else. And so this is the everything else style display because these displays, you have to configure them with SPI, and they're it's not that they're difficult to use, but they're just a little bit more complicated than your plain displays. So maybe I'll show the plain display.
Yeah, I thought I'd hold these up as you start to show these because
yeah. Okay, so this is a plain display. It's rectangular, and it's got a 40-pin connector and a separated capacitive touch. And these do not need any configuration. And they have a very standard pinout, but that's different than there's two pinout standards. So this is your everyday standard pinout, which I'll make a version of the board that also has like the quote unquote standard pinout. But these displays are easy. You don't have to do any configuration with them. They just kind of like magically work. And then these are some of the strange displays. So first up, they come in square. So this is like a 3.4-inch square, and these have a 40-pin connector, but it's a different pin order. But all the ones I'm showing from now on all have the same pin order, but that it's different than this one. So this is like standard number 1, and this is like standard number 2. And these ones have the capacitive touch driver chip. You see, it is a separate PCB, but the PCB is soldered in. So this is like a 3.4-inch square. You can see like this is the TFT, and then there's this ridge where the overlay is bonded on. So this is the capacitive touch square. This is a non-capacitive touch square display, so you can see where the cap touch would be, but it's not there. And this is 720 by 720. I think this is 480 by 480. Here's the 720 by 720, but this one has you can see the ridge again, capacitive touch display. And then so those are the square ones, and then it's like, okay, square's kind of cool and funky. And then you get into like the bar displays. So bar displays are like, as you expect, they're like candy bar shaped. So these are like 960 by 360, and this is like 960 by like 120 or something. So this is a very long display. And then this is also
good for CyberDecks. And we have
960
a floppy drive project.
Yeah, this is actually like
5.25
exactly.
inch
This is exactly like
drive bay project.
3.25-inch drive bay, and this is like a 3.5-inch drive bay. So I thought it'd be funny to make a little like display for your old tower, but they all have this 40-pin. And then I also got a version that has the cap touch. This is the same screen, but this one you see has the cap touch display on it. And then I've got so there's 4 bar displays, and then I've got the round displays. So 480 by 480 round, and it's not like polar. It's as far as the TFT controller knows, it actually thinks it's a full square, and you just don't. The pixels don't show up. So in your software, you have to like cut out those pixels so they don't affect the display. So you can see this is bonded onto the capacitive touch bezel, and then here is another capacitive touch one. This one's huge. I love this one. 4-inch diagonal round display. It's going to be very cool. I think this is like 800 by 800 or something.
So we're going to probably be able to do like a really nice eyeball.
A gigantic eye. Yeah, more eyes. And then this is kind of, I think, the most interesting. This is a half round. So it's like 3/4 round, and they cut. So again, it thinks it's rectangular. It doesn't know that it's like this weirdo shape. But this is for car gauges, for like little car gauges. But I also just like love this cool shape. It's like, I don't know, it's kind of it's funky.
Yeah, it's really hard to do round displays with microcontrollers, like we were just talking before we went live, like the common thing is like, look at this cool display I found on Alibaba,
And then you can't.
or AliExpress,
'Cause you have
or
to configure
Wayshare. Yeah, and then it's like, oh yeah, like I'll get to it one day because there's no drivers actually, or there's a demo and that's the only thing you can do.
Yeah. So luckily,
so we can fix that. We think.
There's two ways we're going to drive it. You can drive it with the ESP boards. The ESP board you can pop up again.
I wonder what happens when I pop up on screen. Oh, it works.
Okay. So it uses a lot of the GPIO, but again, it can only do 16-bit color. But the display is only 18-bit color, so it's like you only lose like 2 bits. It's kind of not a big deal. And you have to use the S3 with a lot of PSRAM. But there's a peripheral to drive TFT displays. And there's a couple of things I want to add. Like I think I can drive the SPI configurator pins from the I2C pins and use the chip select as a like a disconnect. Like I'll connect the pins from I2C or SPI because you only have to configure the display once on boot. And that's it, like saves you 2 pins, kind of like you don't have to worry about sharing those 2 pins with anything else. So you can use them for like I2S. And then the 2 buttons, the thing is I can need like a NeoPixel pin. You got the 16 GPIO pins for the display, plus 4 control, 2 I2C for touch or external, 1 IRQ. It's kind of like all the pins are used. In the end, you have at the bottom like 5 pins left over, and you don't get a lot. So it does use a lot of the GPIO, but there's always expanders you can plug into I2C. And also, when you think about the Pi portal, it didn't really only had like 3 connections left over at the end. So it also didn't have a lot of pins, but at least the memory is inside the PSRAM and the flash memory. So this is minimal. Like I think like, I could add like an SD card maybe, but I don't know.
Well, yeah, like usual, I think we'll see what folks do with this and see what the requests are. And then maybe make some.
Yeah, this is just like my board. I need a board just to like get these things up and running because I've used displays like this before. I used one on the Raspberry Pi. You have to set up the SPI to configure the driver before you can start blitting.
It's a nice glimpse of the future. We wanted to do this for a while, so we're finally here and like get all. He's going to be really
cool weird shapes.
Okay, all right. Well, that is our. That's our show and tell tonight, everybody. Thanks for joining us on this very special CircuitPython Day 2023. We'll be doing Ask an Engineer in a couple minutes. And once again, thank you everyone who participated in CircuitPython Day. We were just saying CircuitPython Day is every single day, but we do have a holiday. I guess I should mention it's a paid day off for our entire team.
Yes.
At Adafruit. So I think we put a notice up. We did get all the packages out, but some folks have the day off. So we'll get to them Monday morning before the next pickup. So Thanks so much, everybody. We will see you next week, Wednesday, 7:30 p.m. Eastern for Show and Tell. And Ask an Engineer is once again next week at 8 p.m. But tonight, a special CircuitPython Day Ask an Engineer. See everybody in a couple minutes.